Graphing linear equations. Alright, so in order to graph a linear equation, there's two pieces that we need to know, and that's slope and y-intercept. And if you notice, our equation is written in slope-intercept form. And when I say that, I mean y equals mx plus b. Pretty standard, that slope-intercept form, where the m is the coefficient, the rate, the slope, whatever you are comfortable calling it with. And the b, that is my y-intercept in my slope-intercept form. So, in order to identify these things, just look at your equation. So here, my slope must be 2. It must be increasing 2 every 1x. And my y-intercept is positive 3. So in order to graph this equation, the place that you should always start, easiest thing that you can do, is start at your y-intercept, which in this case is 3, so I'll count up 3 right there. And then now I know that I am rising 2 and I'm running 1. Remember, rise over run. And where'd that 1 come from? Well, any whole number is automatically over 1. Sorry about that. Okay, so I'm going to rise 2, run 1. That will land me there. Come up 2, run 1. Come up 2, run 1. There. There. I can also go backwards. And then just connect your dots. Alright, so there's the graph of y equals 2x plus 3. Alright, how about this one? Looks a little uglier, but it's really not. My y-intercept here is -1, and my slope is 3 over 2. Now you might be inclined to say, but that's 1.5. You're exactly right. When you're dealing with slope-intercept form, it is okay to leave your slope, your rate, as an improper fraction. It just shows your rise over run a little bit easier. So now I can see that I rise 3 and I run 2. So let's plot this graph. Again, start with your y-intercept, -1, and then rise 3, run 2. So I'll come up 3 and I'll run 2. I'll do this again and again. And then I can even go backwards again. So run -2, rise -3. And I'll connect these dots. And so that's roughly what your graph would look like. Do not overcomplicate this, especially when you see a fraction as your slope. Do not panic. Just think of it as rise over run. The top number is your rise, the bottom number is your run. Your numerator and your denominator. Okay, now we are given the graph, and we need to know what is the equation, what's my slope, what's my y-intercept. Do not panic. This is really, really straightforward stuff. First, start with your y-intercept. Just like you're graphing it, that's where I would start. My y-intercept is the easiest thing to identify, wherever your graph crosses the y-axis. Alright, so in this case, my y-intercept is +3. And I can start to build my equation as I go. Remember, we're dealing with y equals mx plus b, that slope-intercept form. You are guaranteed to have y equals and then an x. You're going to have a slope and you're going to have a y-intercept. We just need to identify it. So in this situation, my y-intercept is +3. So now I just need to identify what is my slope. Choose nice points, and what I mean by that is choose 2 nice points that cross the graph nicely. So let me start by showing you what a nice point is not. That is not a nice point. Okay? This is not a nice point. I would be guessing as to what that point actually was. However, that's a nice point. It crosses the graph on the grid nicely right through there. This is a nice point right there. Your y-intercept is always a nice point. Usually, I shouldn't say always, usually. Alright, so once you've identified just two nice points, it could be any two nice points, just count your rise and your run. So I'm going to go with that point and that point. My rise is positive 2. My run is positive 1. So my rise was 2, my run was 1. My slope is 2. You could call it 2 over 1 if you need to. If you're in my classroom, I wouldn't take off for that. I'd probably talk to you and say, this isn't completely proper, but you could get away with that. So this equation is y equals 2x plus 3. Let's look at another one. Okay, again, what's my y-intercept? In this case, it's 0. So as I build my equation of y equals mx plus b, remember, guaranteed to have that y equals and then that x for your independent variable. In this case, your y-intercept is 0, but that's redundant to say plus 0. I don't think you're going to find too many places where equations have plus 0 added at the end of it. So, for this scenario, when your y-intercept is 0 at the origin, you just leave it as nothing. Okay? So leave it as nothing. That will automatically tell you, if I see my y equals 3x or whatever, or negative 5x, but there's no plus 2 or minus 8 or anything at the end, then you have to assume that your y-intercept is 0, because it's saying plus 0. You have added nothing to the end of your equation. So, now the same process will hold true here. Identify two nice points. So for me, I'll identify this point and this point. Those are nice points. I can tell that they cross the grid nicely. So check your rise and check your run. I have risen negative 1 because I went down, and I ran positive 2. So if I'm doing rise over run again, my rise was negative 1 and my run was 2. There's your slope. Negative half. And again, leave your slope in your equation as a fraction. It just helps you see that rise and that run a lot easier. You could say negative 0.5, but when it comes to graphing, just leave it as negative 1 over 2. I could have chosen this point, and let's go this point. Let's just go really big. So my rise is all the way down there, so that's what? 2, 4, 6, and my rise is negative 6, and my run, count that out, that's 12. So negative 6 over 12, and that does still reduce to negative half. So you could choose any 2 points, and you would still find the same slope. Alright, last scenario, you are not given a graph, you are not given the equation, but rather you're given a table of values. Okay, again, start with your y-intercept. It's the easiest place. You are looking on your table for wherever x equals 0, which is right here. X equals 0, right there. So my y-intercept is 3. And this makes sense too. If you look at it, just a basic graph, wherever my graph crosses the y-axis, x is always going to be 0. The x value in every one of these graphs I just drew, x is 0 because it's along this y-axis. So that's why we're looking for wherever x is 0, that's your y-intercept. Alright, now to find slope, you're looking for that change in y over change in x. Okay? Because this is your vertical change, and this is your horizontal change. And if you don't remember that triangle, that delta symbol, delta means change. So that triangle is just representing change. Okay? So we're looking for rise over run, because vertical is up and down, horizontal is left and right, like horizon. If you're checking someone's vertical, you're checking their vertical leap. Okay? How high can they jump straight up in the air? All right? Like LeBron James's vertical is like 35 plus inches. I mean, 3 feet. Just jump straight up in the air 3 feet. It's ridiculous. But anyway, so we're looking for that rise over the run. Hopefully you've heard me say that enough. It's rise over run. You have to rise before you can run in the morning. So, let me get rid of these notes here. And we are checking the change in y. In this case, my change, I decreased by 4. And you can choose any 2 points on this table. I just chose the first 2. It doesn't matter. So my change here was -4. And my change in x, I've increased by 2. Well, that's looking like it's going to be -2 over 1, which equals -2. Let's check it at another place. How about, oh, here's one. How about from -1 to -11? How much change is that? I've decreased by 10. And I'm showing that decrease by that negative. And I've increased up here from 2 to 7 by 5. You reduce that, that's still going to give you -2. Okay, so to build my equation, guaranteed to have the y equals and the x. What's my y-intercept? +3. What's my slope? -3. Final equation, y equals -2x plus 3. Alright, so hopefully this has helped. If you have any more questions about how to graph a linear equation, how to find your slope, identify your y-intercept, you check me out on Rittman 7th grade math on Facebook, or subscribe to my channel and post comments, ask questions. I will answer them as soon as I see them.